Hello everyone. I'm going to explain you here how you can write the chemical formulas for ionic compounds. Okay. So basically a chemical formula consists of element symbol with a numerical subscript. You may have seen some chemical formulas like this: Na2 CO3, or you may have seen magnesium chloride MgCl2. You may be wondering, how do we get these subscripts and how can we write these formulas? So in this section you're going to learn how to do that. Okay, the chemical formula indicates the type and number of each atom present. Now in this one there are two sodium atoms. Okay, and then you have one unit as carbonate. And in magnesium chloride there are two chlorides but only one magnesium. How do we figure out how many atoms, right? So we're going to learn that. And also these subscripts has to be present in the smallest unit of a substance. For example, in the ionic compound, let's say you have something like this, Mg2O2, and since this is ionic compound, we're going to keep it as the smallest ratio as magnesium oxide. Okay, that is the smallest unit of a substance. Okay. Naming binary ionic compounds. Binary means how many? Two, right? Ionic compounds. So how do you form ionic compounds? What are the type of elements that combine to make an ionic compound? Basically, ionic compounds are formed between metals and non-metals. Okay, ionic compounds are formed between metal and a non-metal. So where do you find metals in the periodic table? In the left side, the blue ones, and then the non-metals are to the right side excuse me, of the zigzag line, and they are normally yellow in color. So ionic compounds form between metals and non-metals. For all ionic compounds, the name and the formula list the cation first and the anion second. Normally, metals form cations by losing electrons, and non-metals form anions by gaining electrons. So cations, normally we write first, metal first and then the non-metal. And in binary ionic compound, both the cation, which is your metal, and the anion, which is your non-metal, they are monoatomic, meaning it has only one type of atom. Name of the cation is the same as the name of the metal. For example, many metals names ends in em. So if you have sodium, we're going to keep it as sodium, magnesium, calcium, barium, strontium, like that, aluminum. So the name of the metal does not change. Okay, but the anion, which is your non-metal, is going to change. We're going to add the suffix IDE to the root of the non-metal name. For example, if you have a non-metal chlorine, we would call it as chloride in the ionic compound. Bromine would be bromide, sulfur would be sulfide, and carbon would be carbide, nitrogen would be nitride, and so on. So between calcium and bromine form the compound calcium bromide. So these are some of the common monoatomic ions. +1. So these are some common +1 charges. So you can see all of these up to cesium, they are in group 1. So the group 1 elements normally makes +1 charge because they can lose one electron and make cations that resembles the previous noble gas configuration. Okay, H plus hydrogen, lithium plus lithium. See, the name doesn't change, stays the same. Sodium, potassium, cesium, and also silver is another element that makes +1 charge. And then these ones, magnesium to barium, they are in group 2 of your periodic table. And group 2 elements has 2 electrons that they can give away and become noble gas configuration of the previous noble gas configuration. Okay, prior to the element. So magnesium, calcium, strontium, barium, they are all group 2. Zinc is not in group 2, but zinc makes +2. Cadmium, that also makes +2. Okay, and then the group 3 elements, main group elements, group 3A, excuse me, atomic number 13 and the prior noble gas neon 10. So aluminum would like to lose 3 electrons and become similar to the noble gas configuration of neon. So aluminum can be 3 plus. Group 3 elements makes 3 plus charge. And then we have anions. We have anions like this. Charge -1 could be if hydrogen take an electron, can become H minus. Now hydrogen has 2 electrons similar to helium. So hydrogen could be H minus, call it as hydride. Fluorine, chlorine, bromine, iodine, they are in group 7. We call them as halogens, and they can take 1 electron and become similar configuration as the noble gas next to these elements. Okay, because right after group 7 comes group 8, which is the noble gas configuration. They are 1 electron away from being similar to the noble gas configuration. So remember, we talk about if you take an electron, it would become negatively charged. F minus, fluoride. See, the name changes. Hydrogen will become hydride, fluorine will become fluoride, chlorine, chloride, bromide, iodide, like that. Okay, and then the group 6, oxygen and sulfur, both of them are in group 6. So 6 mean it has 6 outer electrons. So by taking 2 electrons, it can look same electron configuration as the neon. So since they are taking 2 electrons, the charge that they are making is O2 minus S2 minus. Oxide, sulfide. Oxygen will become oxide, sulfur becomes sulfide. And nitrogen is in group 5. Okay, and then group 5, to look similar to the electron configuration of group 8, it needs to take 3 electrons. So the nitrogen makes -3 by taking 3 electrons, and we call it as nitride. So these are common monoatomic ions. So this periodic table shows us some common monoatomic ions of the elements. So normally group 1A makes +1 charge, and then the group 2A, they commonly make +2. And this is for the main groups. Remember the main groups? Main groups are going to be your group 1A to A, and then 3A to 8A. And this is group 3, normally make +3. And then the group 5 makes -3. So the group 4 could be either +4 or -4. Group 5, common one would be -3. And group 6, -2. And group 7, -1. Those are the common charges that they make when they form ionic compounds. Later on, we will learn that some of these elements can have more than one oxidation state, for example nitrogen, sulfur, but we'll talk about it later. But for now, remember, this is the pattern. Okay, but for the group 1A and 2A, their oxidation numbers doesn't change, whereas the transition elements, which is this is the transition elements, you can see they have more than one type of charge. Okay, most main group elements form one monoatomic ion. Most transition elements form 2 monoatomic ions. You can see these 2. You see some of these makes 2 ions. Writing formulas. Now we're going to learn how to write the formulas, and we need to know the charges of the elements that they commonly make when they are in a compound in order to write the formula. Once you figure out their charges, you're going to write the charge separately. Now, for example, magnesium is in group 2. Common ion magnesium makes is +2. You can refer to the periodic table to find out that. And then the nitrogen is in group 5. The common ion nitrogen makes is -3. And then you're going to write it like this. The charge always write as a superscript. Once you do that, then you're going to crisscross the numerical value of the charge. You take this 2 and then you put it right next to nitrogen as a subscript. You take this 3 from the nitrogen and then you're going to put it as a subscript next to magnesium. Basically, you crisscross the numerical value of charges. Once you figure out your charges, then it would become Mg3N2. And then once you write the formula, you don't write any positive or negative charges. Compounds are electrically neutral. So we want to make sure when you draw the molecular formula, their charges are neutral. By doing this, you are guaranteed that you're going to make your charges neutral. So let's see how the charges of magnesium nitride become neutral. Now we have 3 magnesiums. There are 3 magnesiums, Mg3N2. Now, what is the charge of one magnesium? That's 2 plus. 2 plus, correct? Or I can say 2 plus, okay. And then how many of these are in magnesium nitride? There are 3. So 2 plus times 3. How much is that? Plus 2 times 3 is plus 6. So total plus 6 charges in magnesium nitride. And if you take nitrogen, nitrogen charge is -3. That is for one nitrogen. But in our compound, now we have 2 nitrogens. So 2 times -3 will make it -6. So our negative charge, -6, balance with the +6. So by doing this crisscross pattern and get the correct number of elements, you will make the charges neutral. Okay. And if these subscripts are not in the lowest whole number ratio, we're going to divide them by the greatest common factor. For example, magnesium oxide. Excuse me. Magnesium is in group 2 and makes +2, and then oxygen group 6 -2, and then you can write it as Mg2O2 when you crisscross, but this one you can divide by the greatest common factor to make by 2 become magnesium oxide, MgO. And we do this for ionic compounds only. You will know when we were learning about the covalent compounds, you do not divide it by common factor to get a simplified form for the covalent compounds. But for the ionic compounds, you can do this. Excuse me. Okay. I think your next section starts from here. So I'll stop here.